Hey, people, welcome back to EarthSky. I'm David Adalian, and today we're going to explore a mystery star, and it's flashing at us. Back in May, astrophysicist Andy Wang from Curtin University in Australia and his team unveiled their discovery of a never before seen stellar object. It's a new kind of thing that we don't know much about. And today, Andy is here to tell us about it. Andy, thanks for joining us. How are you, Andy? Thanks for being here, sir.
Good. How are you?
I am very well. Thanks for asking. So, why don't we take a look at the mystery star in question? Here it is. Tell us what we're looking at, Andy. What
Well,
is
actually,
fascinating about this?
yeah.
Go ahead.
So what we discovered is what we called a new long-period radio transit. In short, it's just LPT. So we name it like for after its coordinates. So we call it
Mhm.
ASCAP J1832, which is a weird name, but we just use that. So it is in our galaxy, about 15,000 light year away from the
Oh,
Earth.
okay, so
Can you
tell
hear
us what a
me?
long transient is. Tell us again. I can hear
So
you. Can
like
you hear me?
yeah, yeah, cool. So they have a period much
Great.
longer than the typical dead stars, which what we call pulsars, or like what is called the cosmic lighthouse. And pulsars usually emit radio waves every several milliseconds to seconds. But for this kind of long period radio transit things, they show much slower periodicity from about several minutes to hours.
Okay, so this thing is sending flashes at us, and that's what got your attention. How often is this thing flashing at us? It's not like a pulsar, which is a spinning core of a star that has met the end of its life and is now flashing regularly at us in some light or radioactivity, or not radioactivity. Tell us what it is. You tell us. I'm trying to explain something that you're the expert about. So you tell us, what is it?
Yeah, it actually could be something actually rotating, but very slowly. So what we discover is something emit bright radio waves every 44 minutes for about 2 minutes. So it is much
Okay.
longer than typical pulsar. So it could be something rotating or something just orbiting another thing. So it could be a orbital period.
Okay. So this thing, they haven't been seen before. So I'm guessing that this was kind of a challenge. Can you explain how you spotted it, and was using the different telescopes important for that?
Actually, I would say like using a like state of art telescope or very advanced technology is a reason why we found it. And we usually use the Australian SK Pathfinder or ASCAP, operated by the CSIRO on whatever Yamaji country in Western Australia, to monitor the radio sky regularly, like for example, every 2 weeks. And in 2023, we spotted an extremely bright source near the galactic plane, so that it is in our galaxy. And later on, we use some other telescope to find multiple pulses from the same object. And then we work out, it actually repeating and repeat every 44 minutes. And what more interesting is we also use a new developed system on the ASCAP to independently discover the source. So it is because we use a wide field of view instrument to make this discovery possible. And also
Right.
the X-ray detection, because that is another fascinating fact for this object. The X-ray discovery actually comes from NASA's Chandra Space Telescope, which is now shown in the screen. And that part was actually a lucky break because originally the telescope was actually point to something else, but just by coincidence, it also covered the source as well. And it was conducted during the source to be very crazy bright. So a coincidence like that is really, really rare. So like just like finding a needle in a haystack.
Right. So having the two, you accidentally caught it here in the Chandra, and you were looking at some very precise data. Let's go back over here, and this is from the Australian, the ASCAP radio telescope. And so you put those together, and you were able to discover this object. And does that tell you what it is? Do we know what this thing is here? Here is an artist's impression of a magnetar, which is tell us what a magnetar is, and do you think that's what this is?
Well, magnetar is so like first let me explain what is a neutron star. So usually like if a heavier like star that just go into the end of the life just exploded, and what left is called neutron star. So and also like if something that has a lighter weight, so like something similar to our sun, then what you get is what we call a white dwarf. So for neutron star, like if it possesses a very strong magnetic field, like billion times more stronger than what we have on the Earth, then what that is something called magnetar. And usually magnetar has a relatively slow period, so that is why astronomers think this might be the nature of this source. However, it still is a bit hard to explain all the observational feature to be a magnetar, because like for example, if it is a young magnetar, you would expect to say X-ray emission, even though it is a bit faint in X-ray. And if it is something, it's an old magnetar, then you wouldn't expect to say that bright radio pulse. So all the combination together makes this object a bit unique.
Okay, so this is a real puzzle. Do you have any speculation? What else could it be? Didn't you mention that it might be a binary star of some kind?
Right. So like we have two different scenarios. We can have a magnetar which is isolated, or we can have what I introduced, a white dwarf, but orbiting another star. Its star, not a dead star. So we already know some of these systems are white dwarf binary systems. However, if you compare the radio features or properties for this object to the other known white dwarf systems, then you will see their radio properties are totally different. So maybe this one also it is something different.
Okay, so we don't know what it is yet. How are we going to figure that out?
Well, I wouldn't say
possible?
we didn't know, but we sort of can't exclude some possibility, but it could be something totally new, but it could be also something we've already known, but it just produced a radio pulse and X-ray waves in a totally different ways. So to understand what this kind of source is, we have two different ways. First, we have this special source, so we can keep monitoring it, and hopefully it will just give us another bright radio pulse. And then we have the X-ray as well. Then we can use all those informations to try to constrain the properties of this object. However, we need to be lucky. But this time we will be well prepared, because we know we will schedule our observation instead of using others' observations. So the second way to do that is finding more of them. So the more we find, the better we will understand the same system.
Okay, so you're going to constrain possibilities, and that finding additional objects like this is going to help you narrow down what exactly this thing is. So we found something that might be totally new. We've added to our understanding of the universe, and I think that's what this is all about. And so we need to look more. We need to look at more of these things. What are you and your team doing now? Are you continuing to study this? Do you have other objects under the scope?
Yeah, actually, we still keep monitoring this object because it still emits radio pulses still now, even though much fainter than the time we detected X-ray pulses. So we wouldn't expect to say X-ray pulse now, but we'll just keep monitoring it just in case it just emits a very bright radio pulse. And the second thing is what I said before is we actually trying to looking for some more. And now we've already discovered about 5 to 6 about ish more more similar objects even though some of them are consistent with a white dwarf binary system, but still there are several of them similar to the object we are seeing right now.
Okay, so you're finding a population of these things. That's pretty cool. That's pretty cool. Well, thanks for joining us, Andy, and thanks for finding yet another cool and kind of weird, strange object out there in the universe. We know a little more now, don't we? Really appreciate you being here. Thanks again, Andy. Appreciate your time. We'll talk to you next time.
See ya.
Thanks. Bye-bye. Well, folks, you can learn a little bit more every day right here at EarthSky. We're here every day at 1750 Universal Time. That's right about now. Give us a like and subscribe so you don't miss anything. We'll see you tomorrow. We'll be talking about the lowest full moon in decades. That should be interesting, huh? One Earth, one sky, EarthSky. Bye, folks.